What we're going to do today is lesson 7, which is gradient and y-intercept. Before you went away for half term, in lesson 6, I gave you a handout to do with gradients and y-intercepts. And we called it a flip lesson, and the idea of this was that you went away, you watched the flip lesson video on YouTube, and you used the notes that I gave you to understand what gradients and y-intercepts are. Okay, so I'd like you to carry out these two. So for the first one, I want you to tell me what the result is of -6 plus -2. And then the second one, I want you to fill in the missing numbers within this table. On the first one then, -6 plus -2. What's the first thing I have to deal with there? What's the issue?
Expand the brackets.
Expand the brackets, but if I expand the brackets, all I'm going to have is -6 plus -2. There, I've got rid of the brackets. Because the number isn't right next to the brackets, I'm not multiplying anything, I'm just putting it there to show you that's the number -2. So what's the first thing I need to deal with on that problem?
Look at -6, and then you go to -8, because I'm in number 8.
Right, so you've done something before you've done that. You've actually resolved an issue. We've got an issue here, haven't we? I've got a plus and a minus. Yeah?
Always minus.
Good. So we have a sign rule that resolves that. So in week 1 we did something called the sign rule. So we resolved it by saying the problem becomes -6 -2. And then what James is talking about is, in order to give us the correct answer for this, the way we visualise it in our heads is that we start off at the value of -6. So we start here. We look at which direction we're going. So we know minus always goes that way on the number line. And we're going 2 places in that direction, 1, 2. And as James quite rightly says, you end up at -8. So the result of -6 plus -2 is -8. Okay? And that's quite important with equations, with graphs that we saw before half term. The next one then. Before we start substituting in our values for x, what does that mean? What does 2x plus 4 actually mean longhand? What does it want me to do? So it says 2 times whatever my value of x is plus 4. Okay? So in the first instance, I'm going to swap my value of x for the number -1. So it becomes 2 times -1 plus 4. What rule tells me what to do first? BIDMAS. BIDMAS says I multiply 2 by -1 and I end up with -2. Because it's a positive and a negative, so our sign rule kicks in again, and 2 times 1 is 2. And then I have to add 4. So now my number line kicks in. I'm at -2, visualising going right, because I'm adding 4. So I end up at +2. So when I enter -1 into this equation, it spits out the number 2 for my y value. So I can go to my graph and look, -1, so I go left 1 on my x-axis, and then I go up 2 on my y-axis. Okay? When I put 0 in there, it's the same thing. I'm swapping x for 0, so it becomes 2 times 0 plus 4. So BIDMAS tells me what to do first, 2 times 0. So what's 2 times 0? 0. So remember, anything multiplied or divided by 0 is 0, as far as this level of maths is concerned. And then I add 4, it gives me a value of 4. I then put 1 in for the final time, it becomes 2 times 1, which is 2, add my 4, and I get 6. So my 3 points to plot on my graph is -1, 2, 0, 4, and 1, 6. And the reason this is a straight line graph, does anybody remember why that's a straight line graph? The value for x has an invisible power of 1. Has everybody seen that before? X squared, and we know what it means. What does that mean? X times x. It means x times x, and quite a few people got that wrong in their continuation assessment yesterday. Okay, so x squared means whatever the value of x is, multiply it by itself again. Well, when you see x on its own, like it is here, it actually has an invisible 1 there that we don't write in maths. Like there's an invisible plus, and there's an invisible divide by 1. We don't write all these things every time we write a number, or we'd never stop, messing around with things. So there's actually an invisible 1. So the reason this actually plots a straight line is because x has a power of 1. So let's look at that last example then. Let's lead into today's lesson using that smart example. We had y equals 2x plus 4, and we worked out the values of x, and then we put in the value of x, and we got a value of y, and we said they were 2, 4, and 6. What we did a couple of weeks ago before half term is we then went to our graph paper and we plotted the value of -1 against the value of 2. The value of x is 0, the value of y is 4, and then the value of x is 1, and the value of y is 6. And we plotted a line like that. So as far as you're concerned, up until half term, this is how we plotted graphs. Any line that you have in mathematics can be described using 2 bits of information, okay? This equation describes this line, okay? But this line can be described by 2 things. How steep it is, okay? And where does it cut this axis? So any line in mathematics, any straight line in mathematics can be described by how steep it is or where it's placed. So once you know how steep it is, you can then place it on your axis and you know how to plot it, okay? That information is contained within this equation, okay? How steep a line is the number 2. This tells you the gradient, and we'll have a look at that later. Where it cuts your y-axis, so if I tidy up this graph a little bit, okay, where it cuts the y-axis is what we add or subtract from x. Okay, so the steepness of the line is 2, and where it's placed on your axis is whatever we add or subtract from x. Okay, so let's have a look at these things called the steepness and the y-intercept. So whenever you plot a straight line on a graph, there's only 2 bits of information you need. You need the gradient, that's the posh word for how steep it is, and you need what we call the y-intercept. That's the posh word for where does it cut my y-axis. Using those 2 pieces of information, you can reconstruct from a line that equation you had at the start. Or conversely, if you have the equation, you can use the equation to plot your line instead of plotting 3 points. Okay, so let's have a look at that. Anybody know how to calculate the gradient of a graph? Part of your flipped lesson.
You count how many across and then how many up.
What do you do with them? Which?
You divide them.
What do you divide by what to get gradient?
How, like, vertical line.
Yeah,
You
good.
multiply by horizontal line.
Multiply it?
No, divide.
Divide it, good. So the way we calculate a gradient in mathematics, in other words, how do we know how steep it is the difference in the y values, as Lasma says. So how much does it go up? And we divide it by how much it goes across. Some of you might have done higher mathematics, I don't know. In higher mathematics, the posh word is dy by dx for a gradient. All that is saying is it's reducing this into the difference in y, dy, and the difference in x, dx. You don't have to know fancy terms at this level. You're doing a foundation maths course. You can say the rise, how much it goes up, divided by the run, how much it goes across. So when you're calculating a gradient, you just need 2 bits of information. Where you get the information from is totally up to you. Okay? You can pick any 2 points on your graph to calculate a gradient. Those points, the best points to get, are where they cut a nice round number on the x and y axis. So you wouldn't pick this point here because it's like 3.5. Don't mess around. Always pick nice points that cut an x and y coordinate exactly. So here it cuts 1, 2, and here it cuts 4, 8, quite nicely. So pick 2 points that are sensible, not points that are like in the middle of a line. Okay? That's the best way to do it. It doesn't matter where you pick those points. I could have picked this point here, this point here. It doesn't matter, because wherever you calculate your gradient from, the answer is always the same. There's only one gradient for a line. Okay? So let's have a look at doing this then. Here I've got a rise. My rise is 1, 2, 3, 4, 5, 6. So I've got a rise of 6 and a run of 1, 2, 3. So 6 divided by 3 tells me the gradient of that line is 2. Does that make sense? Yeah? So generally, gradient of a line, dy by dx. So here's another example for you. The rise pick 2 points. This is a nice point because it goes through 0, 0, and another nice point could be there. So my rise is 1, 2, 3, so I've got a rise of 3 and a run of 1. So the gradient of that line, so you can see it's steeper than the last one, is 3. Yeah? Does that make sense? Let's have a look at a shallower one, something that's less than 1. Here, let's pick this point here and say that point there, because they cut the coordinates quite neatly. I've got a rise of 1 and I've got a run of 2. So the gradient of that line is a half. Does that make sense? Yeah? Excellent. So have a go at that. Okay, everyone had a look at that? So what's the gradient for that graph? What does 0.3 mean? What's that mean in mathematics?
1/3.
No, it
3
doesn't.
over 10.
That means 3 over 10. What is 1/3 in mathematics? How do we write 1/3 in mathematics? Remember that reoccurring? Goes 0.333333. A lot of people in the continuation assessment thought 0.3 was 1/3. It isn't. 0.3 is 3/10. That's what this column means in decimals. They are the tenths column. So 0.3 in maths is 3/10. You're correct in that it's a third. The rise is 1 and the run is 3. So the gradient is 1/3. 1/3 as a decimal is that. If you write that, it's wrong. Absolutely wrong. It's a different number total. Let's have a look at this gradient. Have a go at that one then. So
I'll go for 1 across and 5 up.
got 5 up or 4 up?
4.
4 up. So those 2 points there. Okay. So it's what's the rise? The rise is
4.
and the run.
0.
So my gradient is 4. 4 divided by 1 is 4. Okay. So the gradient of this line, as you can see, really steep, is 4. Okay. So that's how you calculate a gradient. It's not magic, but what you have to take into account are negative gradients. So everything up to 12 o'clock, if we call this the y-axis, or 12 o'clock, okay, everything up to that point is positive. Once you go past this point, your x value starts to be negative. So your gradient becomes negative. Instead of going 1 in the positive direction, your run is going 1 in the negative direction. So your gradient becomes negative. So if we look at this example here, the equation is still the same. Pick 2 points that are nice and round. This one and let's say this one.
So -2.
So you've got -2 as your run
-1.
and your rise is 4. So 4 divided by -2 is a minus, 4 divided by 2 is 2. So the gradient of this line is -2. Okay, the equation isn't any different. To calculate how steep the line is, we still work out how much it goes up by how much it goes across on 2 points that we've picked. That's no different, okay? But because our run is going left, in other words, it's going in the negative direction, just like our number line does, our gradient is going to end up negative. So I've gone -2 that way, but I've gone 4 up. So it's 4 divided by -2. Well, a positive divided by a negative is a negative. 4 divided by 2 is 2. Okay? Good. Have a go at that one then. What's the negative gradient there? So which 2 points do you want to pick? 0, 0 is always good.
-3 is.
That's not a good one to choose.
-4.
Yeah, exactly. See what I mean about choose a point that has a nice coordinate. Don't choose -3, 1. It gets hard sums. Don't make it hard for yourself is what I'm saying. Okay, so what's our rise?
2.
Good. And what's our run?
4.
-4. We're going that way. Okay, so I've got a positive divided by a negative, so the outcome is negative, and 2 divided by 4.
2.
No, it's a half. Yeah? If it was 4 divided by 2, it would be 2. But here you're just simplifying. Yeah? 2 goes into 2 once, 2 goes into 4 twice, okay? So it's a half. So the gradient of that line is minus 1/2. Good. Okay, so another one for you. Last one to do on gradients, and then let's talk through this one then. Let's choose 2 points that you want to work with on this gradient. Yeah, that's called the origin. The fancy word for that point is called the origin. Yeah?
Minus 2.
Good, -2. That point there. Yeah? So how much does it go up? Between the 2 points that you've selected, how many does it go up?
3.
Good, so it goes up 3. And how many does it go across?
Minus 2.
Good. So my gradient is minus 3/2. If you wanted to do the maths for that, it's minus 1/2. Yeah? You can leave it like that. That's a valid way of writing it. So minus 3/2, or minus 1.5 if you want to divide 3 by 2. It's 1.5. Okay? So the gradient of that one is minus, because it's left of the 12 o'clock, 1.5. Happy with that? We've just completed gradients. Okay? So, what's a gradient?
Like how steep it is.
Good, how steep it is. And how do we calculate a gradient? What's our equation? dy dx. Difference in y divided by difference in the x. And the plain words we use to describe that. The rise divided by the run. Okay? Don't forget, if the run is negative, if it's going left, then your gradient is going to be negative. Okay? So, to plot a graph, we can use our gradients. We can work out our gradients. When they give you an equation in mathematics, like y equals 2x plus 4 or whatever, whatever is multiplying or dividing x, in this case 2, tells you what that gradient is. So they're giving you the gradient when they give you the equation. Okay? What we will have the ability to do is take a line and create the equation. Or take the equation and plot a line based on its gradient and y-intercept. If we look at y equals 2x, when I put 0 into this, I substitute x for 0, what do I get? Good. When I put 1 in here, what does 2x mean? Good. 2 times whatever x is, so I get 2, and I put 2 in, I get 4. So when I plot my graph, I end up with a graph like this. Okay? When x is 0, y is 0. When x is 1, y is 2. When x is 2, y is 4. So based on what we've just worked out, let's pick 2 random points, this point here and this point here. Let's work out our gradient.
So you go 2 across and 4.
2 across and 4 up. So what's my gradient?
So it's 4, 2.
4 divided by 2, because it's my rise divided by my run.
Half.
So my gradient isn't a half. What's 4 divided by 2?
2.
2. So the gradient of that line is 2. So this 2 here is that 2 there. Can you see the relationship? So when they give you an equation of a graph as y equals something to do with x plus or minus something else, whatever is multiplying or dividing x gives you the gradient. Let's talk about this other piece of information. So we've worked out how to create the steepness of a line. The next piece of information you need is called the y-intercept. That's the only other piece of information you need. It does what it says on the tin. Where does it intercept my y-axis? Okay? So here, my y-intercept, -1. Doddle, isn't it? There's nothing to it. Okay? So when we're plotting an equation, okay, we know our gradient, how to calculate it, and the fact that it's whatever is multiplying or dividing x. The other information you get with a straight line graph is something that is generally added or subtracted to the x. So here, +2, that is your y-intercept. It's telling you where it cuts the y-axis. So even before I've plotted any points on my graph, I know it's going to cut my y-axis at the point +2. Let's have a look. Okay? I have y equals x plus 2. So when x is 0, y is 2. If that's 0, 0 plus 2 is 2. When x is 1, y is 3. And when x is 2, y is 4. So when we plot it, and we get a graph like this, you can see quite clearly that when I plot 0 against 2, 1 against 3, 3 against 4, draw my line, I end up with a y-intercept of +2. So that's what this information tells me. So whenever you get a straight line graph, the two pieces of information you're interested in, the gradient and the y-intercept, where do I place my line, are contained within the equation. Okay? Whatever's multiplying x and whatever is being added or subtracted to x. Okay? So just using two pieces of information, let's make up our own equation for a straight line, and let's show you how easy it is to plot that equation without plotting 3 points. Okay? So what's the first bit of what should we call it? Make up some numbers.
X plus 3.
Just x on its own?
Yeah.
Okay? So y equals x plus 3. That's the line we're going to go for. So the gradient, what's the gradient here? What's the invisible thing?
1.
Good. So the gradient is 1. So what does that mean as far as gradient is concerned? If I've got a gradient of 1,
It's gonna plus 3 1.
how many do I go up against how many do I go across? When it says a gradient of 1, what's my...
2.
When I go 2 up, how many do I have to go across to create 1? 2. Yeah? So, if I go 1, 2 across, I go 2 up. So I have a gradient of 1 on this line. The second piece of information tells me where to stick my line, quite literally. Okay? So, I've got my line, and my line is at the right gradient, because every 2 I go across, I'm going 2 up. Can everyone see that? So I've created a line with a gradient of 1. Now, I need to know where to stick it. This piece of information tells me where that line lives. That line goes through the point, let's grab the line, not the graph, +3. There you go. So I've just plotted that line. Y equals x plus 3 has a gradient of 1, and it cuts the y-intercept at +3. I've just drawn the line. Okay? It's easy to do when you're on a smartboard and you can move things around. It's not so easy when you're doing it on paper, okay? So let's have a look at another equation, okay? Y equals 3x plus 1. 2 weeks ago, you would have picked 3 values for x. Let's say 0, 1 and 2. You'd have put 0 in here. 3 times 0 is 0, plus 1 is 1. 3 times 1 is 3, plus 1 is 4. 2 times 3 is 6, plus 1 is 7. You'd have had 3 points, you'd have gone to your graph paper, and you've plotted your 3 points. What I'm telling you today is we can now look at this equation, and straight away, without plotting anything, without working these out, I know this line has a gradient of 3, because whatever multiplies or divides x is your gradient. And no, it doesn't go through 3. The steepness of the line, the gradient, is 3, so it's quite steep. And it's going to go through the y-axis at the point +1. Before I've even drawn anything, I know what that line looks like. It's quite steep, and it's going to cut the y-axis at +1. Okay? So let's do that then. Okay? Y equals 3x plus 1. When you do this technique, and this is called the gradient y-intercept method, you start here. Where does it cut my y-axis? +1. A lot of you, when you did your continuation assessment yesterday, when you were plotting points, were using dots. When you plot points in mathematics, use a cross, because when you come to draw the line and you use a dot, you're drawing through the dots and they can't see where you've plotted it. So put little crosses on graph paper when you're plotting points. Okay? From this point here, so I know it goes through my y-axis at +1. 3, for every 3 I go up, how many do I go across? Brilliant. Yeah? So my gradient is 3, so the gradient is 3, and that means for every 3 I go up, I go 1 across. For every 3 I go up, 1, 2, 3, I go 1 across. That's my next point. For every 3 I go up, I go 1 across. Lo and behold, I can plot a line without substituting any values based on this equation. Questions. Okay? In mathematics, this format for a straight line, and we know why it's a straight line because x has a power of 1, it could be y equals x, y equals 2x plus 3, y equals x over 3 minus 4. Doesn't matter how these lines appear to you, they're in this format. Has anyone seen this expression before? Y equals mx plus c. M is whatever multiplies or divides x. That's your gradient. Plus c, as we've discussed already, that's where it cuts your y-axis. Okay? So whenever you get an equation for a straight line, it's telling you a gradient and where it cuts its y-axis. If it's not adding or subtracting anything, it goes through the origin. So if it's not plus or minus 3 or 5 or 2 or whatever, if it's just y equals x, you know it goes through the origin. Okay? Because it's plus 0, it's going through 0 on your y-axis. Okay? So, with linear graphs, they always look like this. Y equals something multiplying or dividing x, which we call m, and something being added or subtracted from that. That's the y-intercept, and they call that c. Y equals mx plus c. You don't specifically have to know this. What you need to know is that whatever's multiplying or dividing x is your gradient, and whatever is adding or subtracting from x is your y-intercept. Okay. So, what gradients and y-intercepts? So now I know what gradients and y-intercepts are. Gradients is the steepness of the line. If it's quite shallow, it's a fraction. If it's exactly diagonal, and it goes through 1, 1, 2, 2, and whatever, that's our famous y equals x line, and that has a gradient of 1. And if it's steep, it has a gradient of 2, 3, 4, and so on. Once I get past 12 o'clock, the gradient becomes negative, because my run is now negative. Okay? That's what you need to remember. When you place your line, so once you've worked out what your gradient is, let's say, I don't know, a half, because every 2 I go across, I go 1 up. If it's got a plus 2, that's your y-intercept. If it's minus 3, that's your y-intercept. And that's how you plot lines. So you can look at a line and work out what the gradient and y-intercept are by gradient is the rise divided by the run, and wherever it cuts the y-axis is your y-intercept. So what I'm going to do now is to check your understanding of what we've done this morning. So I'm going to give you a little worksheet. I need to tell you about this. This is part of the curriculum. The good news is it's never come up in an exam. The bad news is there's no reason why it can't come up in yours, because it's on the curriculum. Okay? Parallel lines on graphs. Okay? If you think, what is a parallel line?
Like a word, 2 lines.
2 lines that do what? What about these 2 lines?
They go like the same way.
They both go the same way, they never meet. Okay, the distance from here to here is the same as the distance from there to there, and they never meet. So parallel lines are 2 lines that never meet. In mathematics, on a graph, this means they have the same steepness, yeah? But they have a different y-intercept. So in mathematics, to spot a parallel line, the gradients are the same, but the y-intercepts are different. The gradients are saying the steepnesses are identical, but these 2 lines are placed differently on my y-axis. So if we look at the 2 examples, 3x plus 2 and 3x minus 4, the gradient of the purple line is 3. The gradient of the orange line is also 3. But because they have a different y-intercept, the lines are parallel. Okay? Where are they going to test you with gradients and y-intercepts? They might just give you an equation of a line and ask you what the gradient and y-intercept is. About every 3rd exam paper you will get one of these, where you'll have 2 lines. And the lines will be to do with something like hiring a mountain bike, or hiring a computer game, or in this case, the cost of a gym membership. And the equation will relate to something in the real world, like the cost of plan A to join this gym is £3 a day plus a £5 upfront joining fee. That's what this means, okay? So we're not using x and y, but it's still a linear equation. So instead of x and y, we've got c and d. They can do that, okay? The gradient is still 3, the y-intercept is still 5. So when I plot this orange line, my y-intercept is 5, and my gradient is 3. So for every 1 I go across, I go 3 up. But in these examples, they use different scales. It's not 1, 2, 3, 4, 5, so you can see the gradient easily. It goes 5, 10, 15, 20. Okay. Plan B to join this gym is £2 a day, but I have to pay £10 up front. So they'll give you two things to hire a mountain bike, to hire a chainsaw, something ridiculous like that, hire a solicitor. There'll be an upfront cost, which is your y-intercept, and a daily rate, which is your gradient. Okay. They might get you to plot them so you can visually see when plan A becomes less cheap than plan B. And they'll say, if I'm going to go to the gym for 4 days, which plan am I better off having? Well, here, 4 days, the orange is below the green, so plan A is the better plan to have. Okay? See how that works? So the gradient tells you how steep they are, the y-intercept plus or minus tells you how much your upfront cost is. Okay? So, as a recap, what we've done today, any straight line graph looks like this. Y equals something multiplying or dividing x plus or minus another number. That information is really important because the x tells us the gradient, how steep the line is, and the plus 1 tells us where it is placed on my graph. So here I've got a gradient of 2, so every 2 I go up, I go 1 across, and it's telling me that I cut my y-axis at plus 1. In mathematical terms, you might have seen this in the past. It's called y equals mx plus c. What that means is m is multiplying or dividing x, that's your gradient, and plus c is your y-intercept. It's not fancy, it's not big, it's not clever. It's just saying, I don't know what my gradient is, and I don't know where I cut my y-axis is. How are they going to put this across to you? They love using this format of a straight line for things like joining gyms, for hiring a mountain bike. Okay? The homework I'm going to give you today is going to have lots of these examples for you to practice. At the end of the day, parallel lines have the same gradient but different y-intercepts. So the gradient is still 2, but the y-intercept has changed.
That's
Okay?
parallel.
Sorry?
That's parallel.
That's parallel lines. Parallel lines have the same gradient, so the gradient here is 2. The y-intercept is different, therefore it will draw parallel lines. Okay? Don't forget the gradient is the difference in the y divided by the difference in the x, or if you want to put it in layman's terms, it's the rise divided by the run. Okay? So that is what we missed out of our lesson 2 weeks ago. The idea was that you went away and you looked at that before you came here.